So in this video, we're going to look at integration by parts. It's our first BC technique for integration. And this approach to integration, this technique, is based on the product rule from derivatives. And so I want to start by reviewing that. Derivative of f times g is, of course, f prime g plus g prime f. So what we're going to do is take this rule that we know, and I'm going to integrate each term of this integral. Each term of this derivative. So for my first term here, the integral of the derivative, we know that those undo each other, and so that's just going to leave me with f times g, and then I'm going to have the integral of f prime g plus the integral of g prime f. Now, I will admit, using a little bit shady notation here, this is not completely mathematically accurate, but I think it's a really great way to help us remember integration by parts, remember the rule for how to apply this technique. So what I'm going to do from this point then is just rearrange these terms. I'm going to solve for this term. The integral of f prime g is going to be equal to f times g minus the integral of g prime f. Taking this term and moving it over to the other side with the f times g. This is going to be our rule for integration by parts. Now, I will say that when you see this in textbooks, a lot of times textbooks will use U's and V's, and it will look like this. And so if you see that, just know that this is really the same thing. I prefer to teach it with F's and G's because this product rule, we already know this product rule from derivatives. And so if we're using those letters, then when we write out our rule here for integration by parts, we can just make sure that we have all the parts of the product rule, and we've got our rule for integration by parts in place. Let me do an example for you to show you how to apply this, the integral of x times sine x dx. So here we've got a product, and that's when you want to consider integration by parts, is most of the time if you're looking at a product, this is a possibility. We might first think U sub, because so up until now that's been one of our choices for integrating a product. But in this case, I don't really have a function inside a function, and also, I just have an x out here. It's the same thing in here, so I don't have the derivative of an inside function, and U sub's not going to work. So we're going to try integration by parts. And when we do integration by parts, we're thinking this first part here is going to be f prime g. And one of the challenges of this is choosing one of these functions to be f prime and one of them to be g. And sometimes you're going to make the wrong choice at first, and it's not going to work out. But you just go back to the beginning and switch your choice, and then it will work. I'm going to choose this one to be f prime and this one to be g. And I'll show you why I'm making that choice. I'm going to write this over to the side. F prime equals sine x and g equals x. So now I'm going with my, up with integrals, down with derivatives. Notice over here, I need to know f and g, which we already have, and then I need a g prime, which we don't have. So I've got to figure out f, I've got to figure out g prime. So for f, of course, if we're integrating sine x, that's going to be negative cosine x. Then I'm going to take the derivative of g to get g prime, and the derivative of x is 1. This right here is the reason that I made the choices that I made. When I assigned sine x to be f prime and x to be g, it's because I knew that I was going to be taking the derivative of g, which would be 1. And what happens there is that when I rewrite this as f times g, so negative cosine x times x minus the integral of g prime f. My g prime is 1 and my f is negative cosine x. And then I'm going to put a dx out there to close out the integral. So what happened then is that I lost this x that I was starting out with in my rewrite here for my integral, And so I end up with an integral here that I can integrate. I'm going to rewrite this and move that x to the front, just conventionally. That's what we would usually see. I have minus a negative, so that's going to be plus the integral of cosine x dx. Now I have something here that I can integrate. And that's the goal with integration by parts, is to end up with an integral that you can actually integrate. So negative x cosine x, the integral of cosine is, of course, sine, and then plus c. And that would be our answer. Now, I don't expect you to do this every time, but I do want to show you that this works. Let's check. If this works, I should be able to take a derivative of this and end up with x times sine x, because we just integrated it and got this answer. So if I take a derivative of this answer, I should get what I started with. So let's take a derivative, negative x cosine x plus sine x plus c. And you can see from the derivative, I did product rule here. Derivative of sine is cosine. Derivative of the constant is 0. And I ended up with a negative cosine x and a cosine x, which is 0 out. Negative sine x times negative x, of course, would be x times sine x, which is what we started with to integrate. So it works. Let's look at another example. Integral of x squared times e to the x. Again, we've got a product here. And so that's a sign that we should be considering integration by parts as one of our possibilities. I'm going to start by assigning one of these functions to be f prime and one of these functions to be g. I'm going to choose the x squared to be g. The reason for that is that I'm going to take a derivative of g, and that's going to reduce my exponent, which is going to make the new integral in the rewrite simpler. So that's one reason for making the choice to assign this to be g, which means this is going to be f prime. So f prime equals e to the x, g is x squared. If I integrate f prime, of course, I'm going to get e to the x, and the derivative of g prime is x. So now we're ready for the rewrite. This is going to be equal to f times g, e to the x times x squared, minus the integral of g prime f, so minus the integral of x times e to the x dx. So now if I look at the integral that I have here, it is simpler because this is not an x squared anymore, but I still have a product, and I still can't use u sub or algebraic manipulation or anything like that. Sometimes with integration by parts, you have to do it again. So now we're going to look at this integral and do integration by parts again. I'm going to assign x to be g. E to the x is f prime. The integral of f prime would be e to the x. The derivative of g prime is 1. Now that I've got a 1 here, now I'm going to end up with something I can integrate. So let's go for another rewrite. We still have e to the x times x squared minus, and then I'm going to put this in parentheses, and this is really important because this minus is going to need to distribute to everything in here. But now I'm rewriting this integral using integration by parts. I have a new f and g, e to the x times x, minus the integral of g prime f, 1 times e to the x dx. So e to the x times x squared minus e to the x times x. If I distribute, that becomes plus the integral of e to the x dx. And now we can finally get an answer. Integral of e to the x is, of course, e to the x plus c. One final example here, we're going to do the integral of natural log of x dx. Now you'll notice here I don't have a product. What I have here is a function, though, natural log x. I have no antiderivative for natural log. This is not something I can rewrite into a different form so that I can anti-differentiate. With natural log, the only thing we have a rule for is a derivative. I can take a derivative of natural log. And so what I'm going to do here is I'm going to multiply in a 1, and I'm going to use integration by parts. I need a g and an f prime, and I want the natural log, in this case, to be g, because I have a derivative rule for natural log. So if I make that g, then I can find g prime, and then hopefully we can move on. So if that's g, then this 1 that I multiplied in here is going to be the f prime. So f prime equals 1, g equals natural log of x. The integral of f prime, the integral of 1 is x. The derivative of natural log x is 1 over x. And now let's do our rewrite. This is going to be equal to f times g, x times the natural log of x, minus the integral of g prime times f, 1 over x times x dx. So notice what happens here in my integral. I have 1 over x times x. Those are going to divide out and just become 1. And the integral of 1 is x plus c. And so this expression would be the integral of the natural log of x.